Hello everyone, welcome back to Spectrum classes. This is my third video on the topic term symbols. In my previous two videos, I have discussed about the LS coupling and spectroscopic term symbols and basics behind that. In the second video, I have discussed about the determination of term symbols for a given electronic configuration for different type of electrons. So there I have discussed about the one electron system and many electron systems for non-equivalent electrons. After that, we have to discuss about the equivalent electrons. For example, P2 electrons and D2 electrons. And for that, we have certain restrictions. Permissible term symbols for the P2 and D2 type of configuration can be determined by mentioning the microstate. So it is essential to understand about the microstates. So here in this video, I am going to discuss how to calculate the microstates and how to write the microstates, and from microstates, how one can determine the term symbols. Okay, so I'll start with the video. So what is called a state and what is called microstate? So the atom may have different type of states of total orbital and spin angular momenta. Each state corresponds to the occupation of orbitals with different combination of capital ML and capital ML. And by considering these two, how one can write the microstate. In this manner, we can say the different ways in which the electron can occupy the orbitals specified in the configuration are called microstates of the configuration. So P2 configuration has this many microstates. Here, the number of microstates can be calculated by the formula. Here, 2 into 2l plus 1 factorial. This sign is factorial sign. X factorial 2 into 2l plus 1 minus x factorial. Here L is the azimuthal quantum number and X is the number of electrons. This formula can be simplified further by writing factorial n divided by factorial e and factorial h. So what is this factorial n? N stands for number of vacancies which the particular orbital has. And this is the number of electrons present in the orbital, and number of holes means n minus e is the number of holes. How to calculate the microstates for a given electronic configuration? So number of microstates one must know before writing the microstate. So step number 1, don't consider the completely filled shells, because these are the completely filled, or we can say closed shell configurations. They always give a term symbol 1 as 0. Why it is so? It is so because these are totally symmetric and do not make contribution to the angular momentum. Here I can explain it with the help of the example. Say I am having S2 configuration which is for helium, right? So for this small s or s orbital, we are having azimuthal quantum number L is equal to 0. And if we are going to calculate the term symbol for this, so first we have to calculate the total orbital angular momentum for these two electrons and then spin angular momentum for these two electrons. So first electron is in s orbital and second electron is again in s orbital. So both are in s orbital. For s, L is 0. So L1 is 0 and L2 is 0. So we are having 0, La. Similarly, for S, we are having one is up spin and the other one is down spin. So S1 is, if we consider S1 as plus spin or upward spin, then S2 will be in opposite direction. So S1 is plus half and S2 is minus half. So total spin angular momentum is 0. From these two, we are writing the term symbol. So while writing the term symbol, here for this capital L, which is 0, so we are having S state. So this is a state, right? And now calculate the multiplicity by using this total spin angular momentum. 2s plus 1 is the multiplicity. 2 into 0 plus 1, this gives the 1. Now what about this J? Since L is 0, S is 0, so J is again 0. J is equal to L plus S to L minus S. So L plus S is 0. So we are having this term symbol. Now we are moving to the calculation of microstates for a given electronic configuration. That is the step number 2 stage. So to calculate the microstates, we are having this formula, or n factorial upon e factorial h factorial. So in this manner, if we are going to calculate the number of microstates for this S2 configuration, then S has maximum vacancy, or it can maximum accommodate 2 electrons. N is 2. Number of electrons which are present in this S are 2. Number of holes n minus e, which is 0. So on putting these values in this formula, we are getting 2 factorial upon 2 factorial into 0 factorial. This I am going to solve. So 2 factorial upon 2 factorial into 0 factorial. So 2 factorial is cancelled out by this 2 factorial. So 1 upon this 0 factorial is equal to 1. So we will get 1. So this is how we get 1 value. So this S2 configuration has 1 microstate. How one can write? So this S2 configuration can be written like this. One is in upward direction and the other one is in the downward direction. Or the first one is in the downward direction and the second one is in the upward direction. Only these two states are possible for this S2 configuration. So now we are going to calculate the capital ML. Say this is my S orbital. And for this S orbital, L is equal to 0, as I mentioned here. Here, ML is having, for this, ML is 0. ML for the second electron is again 0 because it is again present in S orbital. So this is 0 again. Now on combining these two, we will get the ML, right? So this ML is equal to 0. For MS, here the first electron, if we consider for this first configuration, my first electron is in upward direction, so MS for this electron is plus half. And for the second electron, this MS is minus half. If I combine these two, then I will get the total MS, which is equal to 0. If I calculate this ML and MS for the second electron, then what I will get? I will get the same kind of values of ML and M. Are you confused? What is these two ML and this ML? If you are confused by considering these two, so I am elaborating these two terms for you. We know the quantum numbers small n, small l, small ml, and this small ms. These are the quantum numbers for writing the electronic configuration for a given electron, right? So what do you understand? For s electron, this L is equal to 0. But I will take the example of p orbital to elaborate all these terms. So suppose I am taking the p orbital, and for p orbital L is equal to 1, right? So how I will write this p orbital? So generally we write this p orbital like this, and it has values plus 1, 0 and minus 1. And what are these values and from where these values comes? This suggests the orientation, right? So ml is equal to plus L2 minus L differing by 1. So this is how one can understand the value of ml. For s, or for one electron, we are having half spin, right? Corresponding to this s, this ms has two values, plus half and minus half. So what we infer here, ms has values plus s2 minus s differing by 1. Now coming to the writing of table. If I write the table for these microstates, so in the first case, we are having this in upward direction and this second one is in the downward direction. But what we get, ml is equal to 0. This one. So this is equal to 0 for the first set. Similarly, ms is equal to 0. So what you have seen here, ml is equal to the summation of small ml. ms is equal to the summation of small ms. Here so many students get confused. What are such values, right? Now, in this manner, you can understand. If I write the configuration for the second set of information, if I write this downward, this upward, then again I will get 0, again I will get this 0. So these two are equivalent. So this state will not be repeated because all four quantum numbers are same for this ML, MS and capital, right? So we are not considering this term again. So this is how one can understand how we can write the microstates. Fine. Now coming to the L and S value. If we are calculating this ML and this MS, then how and why I have write this one? Fine. So this is actually come from here. Similar to this ML, this it has values plus L to minus L. So maximum value is plus L. And for this S, we are having MS is equal to plus S to minus S. So MS has maximum value plus S. Similar to this, we are having this ML has values plus L to minus L. And this MS has values plus S to minus S. So MS has maximum value is equal to S. So here what is the maximum value? Only 0. And what is the maximum value for ML? It is again 0. So in this manner we are getting, rather writing this ML and MS, we are writing capital L and capital S. From the microstate which we have inferred for a given electronic system, these are the total orbital angular momentum and this is the total spin angular momentum, and corresponding to these two we are now assigning the term symbol. So what is the term symbol according to this? For L, it corresponds to the S state, and this from this S we are calculating the spin multiplicity. So 2s plus 1 which is equal to 1. So S1. Now we are coming to the J. J is equal to L plus S to L minus S. So here L plus S is 0 and L minus S is 0. So we are having only one value of J. So this is how one can calculate the term symbol by writing the microstates. Okay, the next example is for hydrogen. Hydrogen has S1 electron, right? And first we are going to calculate the microstate. So writing the microstates, factorial n divided by factorial e factorial h. It can accommodate maximum 2 electrons. So 2 factorial upon 1 factorial. 1 is the electron which is present and number of holes are 1. So on putting all these values here, 2 into 1 upon 1 into 1. So in this manner, we are having two microstates. So two microstates are there. How we are going to assign this? So suppose I am having this first set of information. In this, I considered the electron is in upward direction. So we are writing the values of ML and MS for this given system. Since we are having one electron, so ML capital is equal to ML small because it is one electron system. For more than one electron, we are having summation of MLs, right? So for this set of information, we are writing ML is equal to 0 here for this case. Second case, we are considered next. For this set, we are having MS is equal to plus half because it is in upward direction. This circle suggests the hole, means here no electron is present. For the second case, we are having this ML again 0 because it is in s orbital, but the value of MS change which is equal to minus for the second set of information. For writing the microstates for this set of information, we are having ML is equal to 0 in both the cases, but MS changed. So we have to write both the microstates. In the previous case, for ML and MS, both are same. So only one microstate was there. But here we are having this plus half and this minus half. So we are having different sets of information. From this, I have written L is equal to 0 and S is equal to half. So how it is so? As I mentioned in my previous slide, ML has values plus L2 minus L. Capital L is equal to 0. From here, we infer that L has maximum value 0. Now coming to the ms. Ms has plus s to minus s. So plus s is this and minus s is this. So these two all together give the maximum value of s, which is 1 by 2. So here L is 0 and S is 1 by 2. So from this ML and MS, we get the information about our total orbital angular momentum and total spin angular momentum. And now we are going to write the term symbol from this L and S. So from this L, it corresponds to the S state, and from this we are calculating the 2s plus 1, which is multiplicity. So we are having multiplicity is equal to 2 into 1 by 2 plus 1. This gives us 2, right? So this is how we are writing the term symbol. Now S is half, L is 0, so it will again have value 1 by 2 only. So this is the term symbol for this given electronic configuration. Now coming to the next example, and here I have taken the example of P1. We are having here 1, 2, 3, 4, 5, 6. So maximum 6 electron it can accommodate. Right? Number of electrons which are present here, that is 1. Now calculate the number of holes. So how you are understand this? 1, 2, 3. So 1 electron is present and this is the hole, this is the hole, this is the hole. This is how you can understand. It has 5 holes. Okay. So in this manner you can understand. Now putting all the values over here. So I will put all the values here. So how we are going to calculate this? This is factorial 6 divided by factorial 1 factorial 5. Factorial means 6, then 5, then 4, then 3 up to 1, 2 and 1. So this is the meaning of factorial 6. Now we are writing factorial 1 is equal to 1 and factorial 5 is 5, 4, 3, 2, 1. So in this manner, this will be cancelled out by this. So this is equal to 6. Second shortcut method is this. 6 factorial can be written as 6 into 5 factorial. 5 factorial means 5, 4, 3, 2, 1 is written as 5 factorial. So 6 factorial into, rather writing this, we simply write 5 factorial 1 into 5 factorial. This will be cancelled out by this and 1 factorial is equal to 1. So we will get 6. So this P1 configuration has 6 microstates. So how you understand this? For this, we can write the microstates like this, in this manner. So for this, ML is 1. And for this ML, I have written this 1. Okay. And for this, what value will be the S? So it is plus half. If I consider the second, I'm just going to circle that. Okay, second part. So for this, ML is having 0 value and correspond, because this is one electron system. So ML corresponds to the capital M. So this is 0 and in this it is having upward spin. So that in the next set of information, we are having the values of ML plus 1 again, and this is in the half minus spin, is in downward direction, right? Similarly, the next set, the spin is in the negative direction. So what you have seen here, we have ML values plus L2 minus L. This is given by this set of information. Right. Again, we are having this set of information and we are having S value plus S2 minus S. So what is plus S? Plus S is this one and minus S is this one. So L has maximum value. L is equal to this one, for which we are having plus half, and L is equal to 1, for which we are having minus half. So S has plus half and minus half set of information for L is equal to 1. So we kept L is equal to 1. For this, we are having S plus S2 minus S value. So S is maximum value of S is plus half. L is 1. So in this manner, we have written over here. So in this manner, we are going to write the term symbol for this one. This stands to P state, and from here, if we are calculating the multiplicity 2s plus 1, that is again 2. Since s is smaller than this L, so here this suggests that it is split into 2. So how we are writing this? L plus s to L minus s. L plus s gives us 1 plus 1 by 2. This will be equal to 3 by 2. L minus s, 1 minus 1 by 2, this gives 1 by 2. So if we are reaching up to this, by subtracting 1, we are not having any other value except this 3 by 2 and 1 by 2. So this is the term symbol for this given configuration. Now coming to the next example. So here we are taking the example of S1 P1 system. Right? If we are having this type of non-equivalent electrons, then how we are going to calculate the number of microstates? So for this set of information, we are separately going to calculate the microstate for S1 electron and for P1 electron, and then multiply those microstates with each other. Only then we are getting the total number of microstates for this type of electronic configuration. Let's start with this example. For S orbital is there, so it has maximum occupancy 2. One electron and one hole will be there. So on putting the value here, so 2 factorial divided by 1 factorial is equal to 2. Now coming to the microstates for this P1 configuration. So here P1 is equal to number of maximum occupancy is 6 and number of electrons which are present is 1. Number of holes are 5, 6 minus. And here we are having 6 number of microstates. On multiplying these two, we are getting the total number of microstates present for this given electronic. 6 into 2, it gives us 12. So this electronic configuration gives us 12 microstates. Now coming to the next example, if we are having P1 set kind of electronic configuration, then we are again calculating the same in the same manner. So for P1 first electron, we are having the value here 6 microstates, and for the second electron again we are having 6 microstates, and on multiplying these two we are getting the 36 microstates. Now coming to the next example, if we are having more than 2 electrons, so suppose we are having 3 electrons, so for this set of information or for this electronic configuration, we are just going to calculate the microstates for each of the orbital and then multiply all of them together. And then we will get the number of microstates. So let's start with the D1. So for D1, it has maximum occupancy 10 and 1 electron is present. So 1 electron, number of holes are 9. On calculating this, so 10 factorial will be calculated as 10 into 9 factorial, and that will be cancelled out by this 9. Only then will be the value. For the s orbital, we are having maximum occupancy, number of electrons present, this is 1, right? And number of holes are present 1. So putting these values here, we are getting 2 factorial divided by 1 factorial equal to 2. And now coming to the P1 electron. So for P1 electron, maximum occupancy is 6. 1 electron is there, so number of holes 5. So on solving this, we are getting 6. So on multiplying all three, we are getting 2 into 6 into 10. This gives us 120 number of microstates. So I hope you understand the concept which I have discussed here. So if you like this video, please give me a thumbs up and subscribe my channel. Thank you all. Thanks for watching.